Hey guys, so inside this video, we're going to be dealing with a perfectly elastic collision and the difference between a perfectly elastic collision and just a regular collision, because not only is the law of conservation of momentum held, but the law of conservation of energy is also held. So kinetic energy is conserved. Well, I should actually say that kinetic energy is conserved in an elastic collision. A perfectly elastic collision, momentum is conserved and kinetic energy is conserved. And because of the second fact, this equation comes about. However, I did not include the derivation of that equation inside this video, but I assure you that it's going to be in later videos because it's really nice to see how that comes about. And it's a very interesting derivation, slightly tedious, something that I hope you wouldn't be required to do in a test or something, but it's still helpful nonetheless. So looking at our question, we have a ball of mass 0.44 kilograms moving east at 3 meters per second, and it collides head-on with a 0.22 kilogram ball at rest. If the collision is perfectly elastic, what is the velocity and direction of both balls? So we have a ball A moving east and it collides with ball B that's at rest. What happens when these two things collide? My layman intuition tells me, well, they're going to go in opposite directions, but let's see how that actually works out. So starting off with momentum, I have my conservation of momentum, which says that mass A times velocity A plus mass B times velocity B is equal to mass A times final velocity of A plus mass B times final velocity of B. Now this equation comes in because they're asking me to find two unknowns, and I only have one equation. And if you have two unknowns, you need two equations to solve. If you have three unknowns, you need three equations. However many unknowns you have, that's how many equations you need to solve your system. So this comes in really handy because it relates the final velocities to the initial velocities. So let's actually start putting in some things. I'm not going to, well, yeah, I'll put those in because those are actually going to be pretty convenient later. So for my first one, I have 0.44 times 3 plus 0, because it's initially at rest, is equal to 0.44 times final velocity of A plus 0.22 times final velocity of B. And the second one just becomes V final velocity of B, final velocity of A is just equal to the velocity of A because the velocity of B is 0. So working this out, 0.44 times 3 gives us 1.32. So simplifying this into something that looks a bit nicer, we have 0.44 times final velocity of A plus 0.22 times the final velocity of B is equal to 1.32 final velocity of B minus final velocity of A is equal to 3. I have two equations, I have two unknowns, and I believe that I can confidently solve the system now. So I'm going to migrate up just for the sake of space and continuity. So down here, I'm actually going to solve for this right here, final velocity of B. Final velocity of B is equal to 3 times final velocity of A. Now, generally they call this equation 1, they call this equation 2, they call this equation 3, they say equation 3 is essentially the same thing as equation 2, but they say sub equation 3, substitute for equation 3 into equation 1, because these are the same variables, they're the same thing. So when I get up here, 0.44 final velocity plus 0.22 times 3 plus the final velocity of A is equal to 1.32. And you can always go back to take another look at the equations. I'm just erasing so I can move down in a linear fashion, but I'm going to write this here because I'm going to need this later on. So now I just have an equation with one variable. This is a linear equation. Everything is I have my constants here. I can solve this explicitly. So 0.44 times the final velocity, 0.22 times 3, this is just 0.66 plus 0.22 v a prime is equal to 1.32. Adding the VAs together, I get 0.66 VA plus 0.66, which is equal to 1.32. So I have 0.66 VA prime is equal to 1.32 minus 0.66, and I hope you guys can see where this is going. So I end up with VA prime is equal to this number, and I believe that these two are actually, this is double this. And just to confirm, you have 1.32. You can stick that in your calculator. That should give you 0.66. So you end up with 0.66 divided by 0.66, which leaves you with positive number 1 meter per second. So it tells you that the velocity of A, it continues moving east. However, its velocity is now 1 meter per second. So it slowed down. However, if you think about your other equation now, you think about this. We have to find that. So plugging that in, what happened here is the velocity of B. B is now moving to the east at 4 meters per second. B is moving faster. So ultimately, both of these end up moving in the same direction. It's just this is moving faster and this is moving slower. So the ball at A, it transferred its energy to the ball at B. And because of this transfer, it's now moving a whole lot slower. And also because the ball B was lighter. B was much lighter. Well, A was twice as heavy as B. So it's going to move faster. So as you do these problems, you begin to build up an intuition that the speed and the mass of these objects in the collision, they will determine a lot. And if you're ever curious about it, try working it out and then playing a game of billiards. You'll see that some really interesting stuff happens, because this isn't always going to be the case. You have in some very extreme cases where the object at rest is so much heavier than the object that's colliding with it that nothing happens at all. Or you have cases where objects, they strike each other and one comes to an immediate halt and the other one moves off with the same velocity. So these things are pretty interesting. Nevertheless, I hope you enjoyed this video, and I hope that you have a wonderful time. And also, again, remember to wash your hands.